Hello class, today we're going to talk about section 7.2, which is division of monomials. By the end of today's lesson, you will know the quotient rules for exponents, you will simplify expression with 0 exponents, and you will make sure that there are no negative exponents within your monomial expressions. So, first thing to remember is that a monomial is a number, a variable, or a product of numbers and variables where we have whole number exponents. So that's no negative exponents and no fraction exponents. Rules for simplifying, again a review, but each variable appears exactly once. There are no powers of powers. All fractions are simplified, and the last thing we're going to add in today is no negative exponents. So we're going to show you a couple ways to get rid of those negative exponents. First rule that we have up today is the quotient of power rules. This is saying that when you are dividing two powers with the same base, you are going to subtract their exponents. So, if I were to write this out in the long format, I would have 9b's up top being multiplied. And on the bottom, I would have 5b's being multiplied. So, what we have here is every time a number is divided by itself, so b divided by b, that goes to 1, or we can simply say that they cancel each other out. So b divided by b cancels out, goes to 1, goes to 1, goes to 1, and goes to 1. So what that leaves me with is 4b's being multiplied up top, or a final answer of b to the 4th. If you look back at our exponents, I would have 9 minus 5, which gives me that answer of 4. So that is why this rule works. So if we are looking at simplifying expression, first thing we always want to pay attention to is our numbers. So I've got 8 divided by 2, which gives me 4. 7k's divided by 5k's means we're doing 7 minus 5, which gives me k to the 2nd. Then I've got m to the 10th divided by m to the 3rd, subtracting gives me m to the 7th. And then this last part, I've got p to the 1st divided by p to the 1st. Remember, you can add in those exponents when they don't exist. And 1 minus 1 gives us 0, so that is eliminated from our problem. And our final answer is 4k to the 2nd, m to the 7th. Go ahead and try this one on your own. Dividing, we have 8, and then we've got d to the 2nd and c to the 4th. If you have questions about the quotient of power rule, let me know when you get to class. Our next thing that we have to talk about is a 0 exponent. So any non-zero number, when raised to a power of 0, is equal to 1. So for example, I've got 2 over 7 to the 0 power. The answer is 1. I've got p over n to the 0 power. That answer is 1. Now, you might be wondering why this works. So I'm going to use a little bit simpler numbers to explain this. So we're going to start with 3 to the 3rd power, which is 27. Then I've got 3 to the 2nd power, which is 9. 3 to the 1st power, which is 3. And then I come down to 3 to the 0 power, which I'm saying is 1. If you pay attention, every time you go down by an exponent, what that is really saying is we have one less 3 we're multiplying by. So I started with 27, which is 3 times 3 times 3. 9 is just 3 times 3. So essentially what happened to get rid of that multiplication right there, I divided by 3. That is how that last 3 got canceled out to get us down to the 9. Then I've got 3 to the 1st, which is just 3. So how did I get to just 3? I had to divide by 3 again to get rid of that exponent. How do I get from 3 to 1? I divided by 3. Every time the exponent decreases, that means you are dividing by the base. So 3 times 3 times 3, if I divide that by 3, decreasing the exponent by 1, I ended up with 9. If I divide that by 3, I end up with just a single 3 left, and I get down to an answer 3. When I go down to a base of 0, I divide it by 3 again, and that gives me an answer of 1. So, if that explanation doesn't make sense to you, that is fine. What you do need to remember is that anything to the 0 power is equal to 1. So, go ahead and try this one on your own. The answer is just 1 because we are raised to the 0 power. Next, we have the power of quotients. So what this is saying is to find the power of a quotient, apply the power to both the numerator and to the denominator. So this goes back similar to what we had with multiplication. When there are multiple pieces inside the parentheses, we need to distribute that exponent to both pieces. So in this case, the 2 is going to both the 3, so 3 squared over 5 squared. Again, remembering if we have numerical values that we can solve, we want to solve those. So I end up with 9 over 25. If I come down here to the second example on the bottom, I need to distribute that in to each separate piece that we have going on here. So I've got 2 to the 5th power, p to the, we've got 2 to the 5th, which gives us 10. So that's that power of a power rule. And then on the bottom, I've got 3 to the 5th and n to the 5th, because that n had a single 1 as its exponent to start. So now I'm going to want to simplify that. So when I do 2 to the 5th, I get 32p to the 10th. When I do 3 to the 5th, I get 243 n to the 5th. So that's as simplified as we can go. Go ahead and try this one on your own. So we've got 2 squared y to the 4th, 3 squared x to the 6th, 2 squared is 4, 3 squared is 9, and then we have our variables. If you have questions about this, please let me know when you get to class. Last thing we have to talk about is our negative exponents. So for any non-zero base, the negative exponent is the reciprocal. So what this is saying is I've got 2 to the negative 4th. What this is actually saying is I want to do that reciprocal. So I've got 1 over 2 to the 4th power. If it starts in the bottom of a fraction, we still want to do the reciprocal, and that brings it up to just y to the 4th over 1, or just y to the 4th. Now, again, why does this work? I'm going to go back to the explanation we started here with the 3. So, if I continue this pattern, I'm at 3 to the 0 power right now is 3. 3 to the 0 is 1. So, what I need to do, 3 to the negative 1 power, is going to give me 1/3. Again, this is because I divided by 3 as I am moving down. So if I go to 3 to the negative 2nd power, I end up with 1 over 9 because I divided by 3 again. And this is going to be the same thing as saying I've got 1 over 3 to the 2nd power. So you can see that that negative exponent moves your power to the denominator of a fraction because we continue the pattern of dividing by 3 in this case. So if I come back, our 2 to the negative 4th power means that we are dividing by 2's instead of multiplying by 2's. That's what the negative exponent means, so it needs to be in the denominator of our fraction. So, when we are looking at problems like this, we are going to want to go ahead and simplify. The first thing I would do if I were you is rearrange to get, So now we want to go ahead and simplify. Again, the first thing we want to do is look at our numbers. 2 can't be divided by 10, so I want to go ahead and reduce that fraction, which is going to give me 1 over 5, since both of those can be divided by 2. Now we're dealing with a. We're going to use our quotient rule and subtract our exponents. So I've got a to the second divided by a to the negative third, which gives me 2 minus negative 3. Minus the negative turns into a positive. So I've got a to the 5th power. Since that is already a positive exponent, that is going to stay in our numerator. Next, we've got b to the 3rd divided by b to the negative 1st. When I subtract that, I'm going to get 3 minus negative 1, which turns into plus 1, which gives me 4. So what this is saying is I have b to the 4th power. That is a positive exponent, so it's going to stay in our numerator. The last piece that we're looking at is c to the negative 5th divided by c to the negative 4th. So I've got negative 5 minus negative 4, which turns into addition, and that gives me c to the negative 1st power. If I put that up top right now, we would have a negative exponent, but that is not what we want. So we're going to move that c to the 1st power down to the denominator to make it positive. So when you are solving these problems, if you end up with positive answers, those are going to stay in your numerator. When you subtract, if you end up with a negative answer, that is going to end up in the denominator of your fraction. Go ahead and try this one on your own, rearranging to get rid of those negatives. So when I subtracted, I ended up with n to the negative 5th, had nothing to subtract with, so that stayed put. P to the 4th minus p to the 7th gave me p to the negative 3rd, and r to the negative 3rd had to stay put. Since these were all negatives, everything needed to be reversed, so the r to the 3rd ends up on the top, n to the 5th and p to the 3rd are in the denominator. If you have questions about this or anything else from the lesson, please let me know when you get to class.